Hey, welcome, buddy. I know we just kind of did this last week. It seems like yesterday we were doing something on philosophy of science, but this is actually the one we were originally going to do. We had Rana talking a little bit about philosophy of science, and then Hugh wanted to join, but unfortunately, due to a scheduling issue, they had to do it at different times. So we actually, if you remember last week, had something very similar, but I'm going to do this a little more free form. It's going to be a little more open and just talking with smart people, because that's what I do. I talk to smart people usually about dumb things, but today I'm going to talk to smart people about smart things. And by the way, that was actually something I said to my roommate. My roommate once asked me, he said, "Steve, what do you actually do on your show?" And I said, "I talk to smart people about dumb things." And that's basically it in a nutshell. But anyways, we got Rana back with us today. He's from Reasons to Believe, and he's the Vice President of Research and Apologetics at Reasons to Believe. He's the author of several groundbreaking books, including Who Was Adam?, Creating Life in the Lab, The Cell's Design, and Dinosaur Blood in the Age of the Earth. He has a PhD in chemistry with an emphasis in biochemistry from his Ohio University. And I actually have a couple of his books. Matter of fact, he actually sent me back in the day Dinosaur Blood in the Age of the Earth to kind of look over as a layperson. And it was really good. I actually really enjoyed it. It was very succinct, very to the point. And I actually even noted it to Dr. Mary Schweitzer, who's been on the channel before. But Fuzz, welcome back, man.
Yeah, thank you. It's great to be with you guys again.
I'm so happy to see you, because I was just telling you before that I went to the AMP convention to meet a bunch of the Reasons to Believe people, and you were the only one missing. It was notable. And I was a little disappointed, but I know you had to be somewhere else. But one of these days.
Yeah.
And we also got with us Dr. Garte, who's also a biochemist.
Hello.
You want to say anything about yourself, Cy? He's like, "Hey, what's up? That's me. I'm Cy. Y'all know me by now. I'm everywhere."
I'm kind of boring at this point. Yeah. Okay. For those who have never watched the old Non Sequitur show and haven't seen me before, I am also a biochemist. That's true. I began life as an atheist and remained an atheist for the greater part of my life, and converted to Christianity about 20 years ago. And I retired. I was a faculty member at several universities, and then I went to NIH for a few years. I retired about 4 years ago, and now I'm mostly working in the area of science and faith. And I have a book coming out in a few months, which I'm not going to talk about much now because it's too early, but it's just about ready it's in production, so I'll bring it up some other point. And I'm also the editor of an online magazine called God and Nature, which is put out by the ASA, the American Scientific Affiliation. And you can find that at godandnature.asa3.org. And that's about it.
Awesome. And we also got the lovely Dr. Misha Griffith back with us, one of my all-time favorite guests.
Hi, Steve.
Hey,
hi, everybody.
Welcome back. I'm so thrilled when you're here. I'm just like giddy.
Stop it. I'm Misha Griffith. I'm a historian of technology. I teach mainly survey courses, and I introduce my freshman students to history of Western civilization, world history, and I take it from a STEM attitude, science and technology sort of methods of inquiry. So I'm here to learn from these two gentlemen more about this science of philosophy. I'm also here to fill your gaps, Steve, in your historical knowledge.
Please, I have a lot of them, I assure you. I told you before, when I took history in college, the instructor actually gave us the exam prior to the exam, like the actual exam, and said, all you got to do is take it home, find the answers, then regurgitate it on the test. I'm like, I've never heard of such a thing. This was a practice unbeknown to me. I had no idea that this was actually, most people would actually, like, back in the day, you had to, like, I guess people cheated by breaking into test banks and trying to get the actual exam. But no, he gave it to you. I was like, this is a real class? It was pathetic. Mm-hmm. Anyways, I aced it, by the way. But anyways, so Fuzz, why don't you kind of, like, dive into this topic of the philosophy of science, because this is kind of what we were talking about initially on Facebook, and I think maybe was it on Twitter? Yeah. About what you wanted to talk about on it, and from your perspective, why philosophy and science is so critical. Because I personally hold all philosophy is important, and especially when it comes to science. Without it, science to me is just useless.
Well, maybe just as a way to kind of open up the conversation, as someone who went through a typical science training, didn't really have much exposure to philosophy as a student of science, other than a single undergraduate course that I took, kind of an introduction to philosophy, which I actually enjoyed enormously. And particularly the philosophy of religion portion of that course, by the way, even though I was a science student. But to me, as a graduate student, as a postdoc, beginning my career as a scientist, I never really truly appreciated what the philosophical undergirdings of science actually were. And I operated in a context of methodological naturalism without really even knowing what that term truly meant. We were just inculcated, and this is how you do science. You look for mechanistic explanations to the universe and phenomena in the universe. That's what science is all about. And of course, the scientific method is a very powerful way of knowing about the world around us, and even a very powerful method that can be applied to areas outside of what we would normally think of as being science. But I really didn't have, again, much exposure to philosophy. And I like to say, and Cy may disagree with this, that scientists typically are very well trained, but very poorly educated. In the sense that there's not a lot of attention given, I think, to the history of science, to the philosophy of science, to augment, I think, what students of science are learning in their graduate programs. And I think that's actually to the detriment of the scientific enterprise. And it was really years later when I became interested in science faith issues myself. Now, I actually was an agnostic in graduate school, and I came to faith in Christ in part because as a graduate student, I really became appreciative of the complexity and the elegance and the sophistication, the ingenuity of biochemical systems, and became convinced that there was a mind. And shortly thereafter was challenged to read the Bible by a pastor. And I felt that Christianity really explained the human condition. And so I converted to Christianity. But I never really gave much thought to science faith issues until many years later, when my wife, who was teaching a biology class at a local community college, had her students do a paper on creation and evolution. And she went to the local Christian bookstore and bought all kinds of young earth materials. And this was my first exposure to young earth creationism, and I was frankly horrified what I saw. And I could finally understand why so many people who are scientists had such an antithesis towards Christianity if this was the type of material that was being presented as scientific evidence for the Christian faith. And that got me on a journey that really culminated many years later with my joining Reasons to Believe, where I suddenly became really interested in science faith questions, and through the process began to read inadvertently first, but then was directed through my reading of other people into textbooks on the philosophy of science, and realized many times a lot of the issues that center around the science faith quote unquote conflict, or the science faith conversation, are really philosophical issues first and foremost, where then the science actually later on, the scientific evidence actually then can inform that conversation. So I'll start off by saying that, I think the philosophy of science questions are really very important. And as a result of that, I think that if you have a really robust conversation about the philosophy of science, it actually opens up, I think, pathways to legitimately look at things like intelligent design as actually having a place in the construct of science. And that'll be a kind of a controversial statement I'll make just to get the conversation going. And I think many times intelligent design is excluded from the construct of science because of underlying philosophical issues that aren't properly identified and really deliberated on.
Yeah, and it's funny you kind of mentioned that. Tomorrow, actually, I'm arranging something on intelligent design. We're going to have a discussion with a younger creationist / ID proponent, with somebody who actually knows a lot about intelligent design and can talk about it from the other side. So it's kind of the theme this week. It seems to be more of intelligent design. And then I believe, Cy, you have something that you're doing with intelligent design as well, right?
Well, yeah. I mean, my main comment about intelligent design is that I don't like the title of the term, and I'll explain why. I don't think any of the Christian scientists that I know, the Christian biologists that I know, would hold that life is not designed. I think that it's clear that there's evidence of design. In fact, even many prominent atheists like Richard Dawkins will agree that life appears to be designed, but it isn't really. Well, we tend to think, yeah, it really is designed. But the reason I don't like intelligent design, that word, is I think it kind of demeans the design. I think the design of life is way beyond intelligent. I like to use the term, I kind of made it up. I didn't make it up, I've seen it, but I like to use the term divine design, because I think life is designed in a way that no intelligent person could even dream of. In fact, we still don't know many of the details of how life came about, most of the details about how life came about. So, the most intelligent group of folks in the world could get together and they couldn't design life from scratch. We don't have a clue how to do that.
So it's basically teleonomic versus teleological.
Yes. So, and that's an important point, and I think that's one of the things I wanted to ask Buzz about in terms of philosophy of science. I think one of the big issues, and actually probably Misha, everybody can jump in on this. One of the big issues I think that keeps coming up in discussions of philosophy related to theology and science is the whole issue of teleology. Mm-hmm. Is there a purpose to the universe? Is there a purpose to life? Again, everyone will agree that it looks like there's a purpose. Okay, the mouse runs away to avoid getting eaten, and the cat chases the mouse to satisfy his hunger. So, okay, that looks like there's purpose in biological activity, but my view is that goes very, very, very deep, all the way to the core essence of biology. And that's a philosophical idea, but I'm just curious what you think about that. Both, everybody, actually. Maybe start with Buzz.
Okay. Well, I actually am strongly sympathetic to your point that, maybe intelligent design is a moniker that actually doesn't do justice to the design that we see in biology. And I agree with you. The appearance of design is quite impressive in biochemical systems. It's quite impressive in biological systems. And, it seems to me that the more that we, uncover about how biology works, the more ingenious and elegant and marvelous life appears, not less. And in fact, what I like to catalog, though I don't do this systematically, are examples where, as life scientists, we thought that a particular system made no sense. There was no real rationale for why it was. It was just a contingent outworking of an evolutionary process where systems were kind of cobbled together, and this is kind of the way the system wound up. And yet, as we begin to delve into the workings of that system, we wind up seeing that there's actually a deep rationale for why it is that way, and it's incredibly clever and it's incredibly ingenious. And so I'm sympathetic to your point, and even this idea of biomimetics and bioinspiration is really intriguing to me, where designs in biology and biochemistry are inspiring new technologies and many times suggesting ways to solve problems that we otherwise would never have even had a clue about. And that to me is real provocative, against highlighting, I think, the fact that there's a design here that probably is far beyond, what we could even begin to imagine. And I think as we begin to do work in synthetic biology, you made the illusion of trying to create artificial cells, protocells, and as we try to engineer new life forms, to me, consistently, what I see in synthetic biology is, again, just how incredibly knowledgeable and how brilliant the research strategy has to be to affect positive changes in organisms, or to even begin to assemble entities that are even remotely assuming some of the properties of life, the level of ingenuity. And I think that, again, highlights your point about the depth of the profundity of the design in nature. So I'm strongly sympathetic to your point about that. And, I tend to use the term intelligent design simply because, well, for two reasons. One is when you use that term, it's a convenient placeholder for the average layperson who has heard that term. So some of it is just convenience, really. But I also like to use that term because I think that the intelligent design movement, and many of these people that are part of the movement I would consider to be friends, but I've also rubbed some of them the wrong way. But they've tended to co-opt that term intelligent design and have forced it to mean something very specific. And so I like to use that term and intentionally conflate it with creation, or the divine, the work of a divine mind, simply to make the point that really when we're talking about the design in nature, we all know what we really mean by that. And so let's not try to produce a concept or a term as to try to convince people that we're talking about something that we really aren't, just to make something more palatable to a secular world. Let's just call the design what we really think it is. So I actually like your idea of divine design. I may steal that and start using that in my blog articles.
We do that all the time. We just borrow from things that other people. It's fine.
I'll give you credit, though. I'll give you credit.
Yeah.
I'm not sure if I answered your question or if I just meandered there.
No, you did. And let me just say before Misha comes in, I think what you just said about the ID folks pretty much pretending that what they're really talking about is methodological naturalism science, and it's really not, is really right on. I mean, we all know the history of ID, and maybe Misha can jump in too on this, but the history of it was sort of to try to get the idea of creationism into the scientific classroom and all that stuff. And I think that that should happen at some point, but not now, because we don't really know how to do it. And I liked what you said earlier about, ID eventually having a role in science, and I think that's right. And I think it's going to be right because eventually the teleological issues are just going to become overwhelming. And in biology, I think what's going to happen, and this is going way out on a limb, is going to sort of what happened in physics, where all of a sudden physics began to look a lot like metaphysics. Talking about imaginary numbers and all kinds of weird stuff that the physicists now take for granted. And we're going to have that in biology too, and it's going to force us to look at this whole design issue. That's my prophecy. When it happens, I don't know.
And just for the record, and I know Misha wants to jump in, and I apologize if it feels like I'm dominating. That's not
supposed to. It's just
okay, but just for the record, at reasons to believe, we've gone on the record as saying that we really are opposed to intelligent design being brought into public high school education, because we really, I think design detection is actually legitimately part of the scientific construct. But I think once you go beyond that point, you really are in this netherland between science or in philosophy or theology, and we need to be sensitive to that. But I think ultimately, if design is going to work its way into science education, particularly into biology, it's got to come from the top down, where the people at the top levels of science are introducing design and let it filter in. And I think, a beautiful example of that would be, as you mentioned, what happens in physics, where, okay, we're discovering that the universe appears to be fine-tuned. And for, I know that there are a few physicists who would reject that idea, but by and large, it seems like both theists and non-theists more or less agree that there seems to be, there's a fine-tuning there. Now, the question then becomes, how do we interpret that fine-tuning? That's where the metaphysics becomes a lot of fun. But to me, I think that's the approach where you can have the concept of design maybe one day in biology in a parallel manner to what we see in physics, but it's got to come from the top down. And so if we to try to, through grassroots efforts to commandeer the science education process, is really not the way to go. It doesn't respect the whole process of the scientific enterprise, and it doesn't respect the science education, right? So We haven't made a lot of friends, by the way, taking that position, but until you can actually show it's genuinely science, then it doesn't really belong in science education.
Yeah, I think everybody would agree with that. Dr. Misha, do you want to touch on that? But real quick before you do, there is a lot of baggage with that term intelligent design. I'm not a proponent of ID. I do think that it was originally just another term for creationism that they were trying to whittle into the school system. But I do want to thank, by the way, before I go too further, I forgot, Biblical History Skeptics, who you can see as the name right down here. I want to thank him for the use of the Zoom today. So if you haven't checked out his channel, it's in the video description. So I want to thank him for that. But Dr. Griffith, go ahead. It's all yours.
That introduction of creationism into the American schools, I mean, we have to point right at the source of why that happened, and that's because our school system is funded on a local basis. The community's tax dollars, property tax or however that system is set up, goes to their schools in that area, and they have traditionally had a say in what's in those schools. If you were to go to almost any other developed country in the world, the school system is funded, of course, by the government, the federal government, and so they don't have these kind of questions and arguing back and forth. So a lot of the rest of the world looks at us a little bit askance as to why this is an issue in our school. But I have to really respect Fuzz and Cy for allowing the science to stay science, and that looking into reasons why this happened, maybe if we can keep the theological aspect one step away from let's do the science, I think we'll have a much more healthy approach.
Yeah, and if they found ways to, I've always said, look, if ID is a viable hypothesis, if there is something that's testable, it is something that can be incorporated with science, I'm all for that. Let them try. I've never said don't do the experiments, don't do the hypothesis, don't spend your time wasting your time with ID. If there's an intelligence there, I would like to know. I think it's a perfectly fine question to ask, philosophically speaking, and even scientifically speaking. But I do stand with Fuzz on the fact that it is not at the point to teach it in any kind of science class. And I think that's the problem, is that when they were trying to interject it into the science class, most people were like, no, we're not trying to do that. It's not ready for that yet, right? Would you kind of agree on that?
Yeah, do not let the ideology, what's the term I'm using? Don't let the ideology, kick the train off of the track. Keep that train going with the engine of science. Students need to learn so much that just throwing this into the mixture and saying, look, your family supports ID, therefore you should support ID, therefore you should fight against your biology instructor in high school and say these things. I mean, putting out pamphlets to how to, negate your biology instructor, that sort of thing. That's derailing the whole process. That's not doing anybody any good.
Completely agree. Yeah, and so Fuzz, you want to talk a little bit about maybe what scientific methodological is for, as far as like the philosophy of science when it comes to, instead of being like an ontological naturalist, but methodological naturalism, and why we do all advocate to keep something like ID out of science right now until it can actually be incorporated in science, if it ever gets to that point. I personally don't think it will, but you guys do. But why do we have methodological naturalism for philosophy of science?
Yeah. Well, and I think most people are familiar with what methodological naturalism is, which is essentially, this is the way I would describe it, but maybe others would describe it differently. Is essentially it's this idea that when we engage in the scientific enterprise, we function methodologically as if there is no supernatural. That in other words, we're looking mechanistic natural process explanations for the universe and phenomena within the universe. And I've given some thought to, what is the genesis of methodological naturalism? And I think ultimately, as I've read people on this, and I don't know that I would call myself an expert on this, it is that to me, it seems as if methodological naturalism is really flowing consequentially out of the ideas that the scientific method is really what defines science itself. The idea that you're positing some kind of model and you're developing ways to test the model and to determine whether or not the model is valid or not through observation and through experiment. And so limiting explanations to the natural realm or to mechanism is essentially almost a demand of the scientific method, in this sense that unless you come up with a way to test for the supernatural, you really can't incorporate it into the scientific enterprise. And of course, methodological naturalism says nothing about whether or not God exists or not. It's distinct from philosophical naturalism. Although, if when you're doing science, in a sense, philosophical naturalism and methodological naturalism would lead to the same kind of scientific enterprise. And so in some respects, when you're doing science, you don't know philosophically or not whether or not somebody holds to the idea of the supernatural. So I've sometimes heard methodological naturalism be referred to as provisional atheism or benchtop atheism, where you're kind of adopting, if you will, in a sense, an atheistic worldview specifically for the activity or the operation of science. And so that's how I would define methodological naturalism. Now, my sense is that methodological naturalism, I think, I'm have no beef with it whatsoever. But I do think that there are places where methodological naturalism can actually inhibit or restrain science from its true power and its true potential. Because I do believe, for example, there are instances where science does, or methodological naturalism does take you up to a boundary, and yet it seems like the data is suggesting that there may be more going on than what would simply demand a mechanistic explanation. And at that point, methodological naturalism may artificially constrain the scientific enterprise, and in doing so, I think somewhat emasculate science in that it no longer is a powerful tool to discover what is approximating truth about the world, but rather is now forcing you into an arena where there's only certain categories of explanation that become viable. So anyway, Misha, I'd be curious to see your commentary on my comments.
Well, let me start out by just saying that I agree with everything Misha said, and Fuzz as well, and Steve, about education. I mean, we don't really teach, quote, science until it's very well established by the scientific community, and then we teach it in lower grades. We might mention speculative stuff in graduate students, but we're not. I remember learning about the universe being steady state, 25 years after the Big Bang Theory had been, well accepted, because it takes that long for new scientific developments to filter down to the lower levels of education. So there's no question that all the comments that I made and it was made earlier about, design and all of that, we don't have any, we're nowhere near the level of certainty or even close to that to be able to talk about that in a scientific classroom. That is absolutely, true. In terms of what you just said, I completely agree with that. And again, I think we see the demonstration of your points about, limits to science, as you put it. We see that again in physics. I mean, and here I'm going to talk about history a little bit, so please correct me, Misha. But, the history of physics is fascinating, because in what was it, around 1900, I think, there was a book published by Lord Kelvin, and in that book, he quoted some people who said, well, we're really done. Physics is done. There's a few decimal places that have to be filled in. We know all the laws. After Maxwell's equations, there's really very little left to do. Of course, we don't know much about biology, but, biology used to be considered metaphysics. It wasn't really considered real science, because there were no equations, there were no laws, none of it was messy. I mean, how do you do a science of biology? I mean, Darwin was really sticking his neck out even to propose anything scientifically. And what happened after that was, several revolutions, among which were, of course, obviously relativity, quantum theory, which threw physics way on its head, and no longer was physics and science in general considered to be this nice, logical, rational, reasonable, you do the experiment, you get the results, they make sense. They explain the natural world beautifully, like a machine, and you keep going. No, that was dead. And not only that, but, with Mendel and then others who started looking into biology, into biochemistry, as a matter of fact, and Buzz will agree with me that biochemistry is, in fact, the queen of all the sciences. When that started happening, people said, well, there's actually science in biology as well. Maybe it's not metaphysics. Maybe it's real stuff. And so we're way behind the physicists. But, I think it's true that we're going to hit those limits that Fuzz mentioned in biology as well. And the result won't be an end. The result will be a revolution, as what happened in physics. And, if you think about it, physics, of course, there are many branches, but there are some branches of physics where the only way you make progress is with mathematical and theoretical work. You can't do the experiments anymore. So who knows? I mean, it's a fascinating, wonderful time to be a scientist. I think clearly we have to stick with methodological naturalism. Otherwise, whatever we find out, we'll never know if it's true or not. And but we'll have to expand, because if Heisenberg had said, no, this doesn't make any sense. How could this be true that we can never be certain about the position and the momentum of the electron at the same time? That's just not logical. It makes no sense. Forget about it. And if Planck had said, how does it make sense that that you go from one energy level to another energy level without going in between the two? You just jump from one to the other. Sounds like science fiction. And if they had said, no, this can't be true, this doesn't make sense, we wouldn't be where we are today. We wouldn't be having this conversation, among other things, because we wouldn't have the technology. So, we may have to be brave in biology as well. And I'm, again, agreeing largely with Buzz. We'll get to some disagreements shortly. But so far,
hopefully, this is too much of a love fest.
Oh yeah. No, we're just paving the way.
Misha will throw that grenade in, and then I'll throw my 2 cents in for what it's worth.
Yeah.
But go ahead, Misha. Dismantle this for me.
No pressure, though. No, honestly, I know someone in the live chat is going to be smart enough to remind me who was the physicist who said real science is physics and all the rest of the sciences are just stamp collecting. And he said it at the time when literally biologists and botanists were, picking up bugs and sticking them in the catalog. Right. Cataloging is done. Right. With biochemistry, we're gaining that technology that we can do something with what we're learning. And this application process is so exciting that it's what frightens me the most is to have an ideology come along and start to put the brakes on it. I'm looking back historically at the time of scholasticism during the Middle Ages, in which you had Roger Bacon and a handful of other ingenious people, William of Ockham, Thomas Aquinas. And for the most part, they're trying to take this logic and science and rhetoric they got from the Greeks through the Arabs, and they're looking at it with Christian theology and basically trying to say, how do we make it work together? How do we make one make sense of the other? That was scholasticism. And finally, with William of Ockham, Ockham says, let's let the God stuff be the God stuff. Let's let the natural philosophy, as they called science back then, let's use that empiricism, that way of doing things. And I just fear with looking too much at purpose of an exterior source rather than purpose based on what we're actually finding inside what we're looking at. I fear trying to mediate rather than exploring.
Oh, by the way, that was Lord Ernest Rutherford that said that, and
thank you very much.
Yeah, and also I did remember the quote. I actually had looked this one up. This was from Lord Kelvin. He actually said, "There's nothing new to be discovered in physics now. All that remains is more and more precise measurements."
Yep.
Okay, so let me throw my 2 cents in, because I do think very strongly that science should adhere to methodological naturalism. Now, granted, whether you take methodological naturalism or you take philosophical naturalism, they're going to get you the same thing as far as being what you guys would be calling an atheistic position, such that there is no supernatural causation. But I'm fine with that, because I think science is the tool we use to look at a natural observation of something and say, okay, this is a phenomenon that is in nature. We would like to find a natural explanation for it with science. Now, let's suppose that there is ID. Let's suppose there is a supernatural. That's fine, but then science wouldn't be the tool that we would use for that. That's when we would go to philosophy, and philosophy would say, okay, now how do we detect something that is supernatural? How do we detect ID? I think it's a lot more in the non-methodological realm of science, or philosophy, than it is science. Now, could that ever get to the point where that becomes somehow natural and science incorporated? Possibly, but I think that still science is always looking for a naturalistic explanation. That's what science does. Even if there is a supernatural causation, I still think that there would be a reason to have strictly naturalistic explanations for a phenomenon. So in that case, I don't think we should ever remove the methodological naturalistic approach from science. And even still, it by fiat basically eliminates any chance of having some type of positing of, let's say, okay, well, here's a phenomenon. You know what? We're going to posit that leprechauns did it. And I hate those kind of analogies, because I think they're really kind of mundane. But in that particular case, there's a million different bare possibilities of things that could be posited for a natural explanation. But I think with science, it builds upon precept by precept. So we know a little bit about something. We can make a guess, and then we can make a conjecture, and then a hypothesis, and eventually a theory. That's the building blocks by which science operates, and I think that's very effective. I don't really think of I can't think of off the top of my head how much different we can do it where it's any more productive to give us any explanations for anything that will not only explain but make predictive things that we can test for.
Yeah,
I don't think anyone disagrees with you, Steve. I think both Buzz and
people
I
disagree with me all the time, man. Are you kidding?
Well, no, I mean anyone sitting here. Anyone sitting here. I think Buzz and I both, said exactly that. We're not proposing, doing away with methodological naturalism. We're proposing, if anything, we're speculating. At least, I think both of us have speculated about what else one may need to use to reach truth. And you just said it. One good approach is philosophy. This raises the whole issue, the philosophical issue of what's called scientism, which is the idea that methodological naturalism, everyone agrees, that is the way to get scientific truth about the natural world. But what not everyone agrees with is the idea that it's the only way to get all truth. And some people do hold that position. The new atheists hold that position. I think most social scientists would disagree with that idea. There are other ways to seek truth other than methodological naturalism. How do you get truth in history? How do you get truth in philosophy? How do you get truth in arts, etc.? So that's a separate issue, which people will disagree about. But in terms of the natural world, absolutely, methodological naturalism is the only way to go. And the point I tried to make, I didn't make very well, is that methodological naturalism has historically changed its definition as science expands. And I think that evolution, if I may, of the methodological naturalism may very well continue.
No, I definitely agree with that, and I think everybody else does as well.
That's all I was trying to say.
So let me ask Fuzz then. So when we're talking about ID being incorporated in some kind of philosophy of science, since it's not going to be incorporated into science directly, at least not now, what would be something that reasons to believe posits, and I think I know I've asked this question before, but I want for the people that are joining us, because I have a lot of new people to this channel, to actually for you to put forth the RTP kind of model, because you guys actually promote there are testable predictions for some kind of intelligent design.
Yeah, and a couple things, kind of all at once here, but just building off of a point that Cy made before I take on your question is. I can remember a number of years ago, I was giving a lecture at a university, Cal Poly San Luis Obispo, and on basically kind of a watchmaker argument for God's existence from discoveries of from biochemical systems. Sorry, having trouble getting that out.
Okay. All of a sudden. If you can't, then I won't be able to. That's for sure.
But anyway, and so during the Q&A, a young man stood up who was clearly coming at this from a skeptic's vantage point, and he just said, "Nothing that you said matters because it's not science." And my response to him is like, "I agree with you. I'm not making a scientific argument here. I'm making a philosophical argument, but I'm informing the argument with science." And so saying that just to say that I recognize again, really what the constraints of methodological naturalism are and why it's important. But I actually do believe that it may very well be possible to begin to broach the question of the divine from within the framework of science, respecting methodological naturalism. And so, for example, I do believe that design detection is actually legitimately part of science. And for example, we look at work that anthropologists do, where they're picking up a rock and trying to determine, is this rock the work of a hominin of some sort, or is it shaped by some kind of natural processes? And they can determine, okay, this rock was fabricated by the work of a hominin. And based on the nature of the rock and some inferences about what would it take to produce the rock in such a way so it would serve as a tool, they can give some assessment as to the capabilities of this hominin, the cognitive capacities and the dexterity of the hominin. And so, it seems like anthropology, archaeology are really great case studies to suggest how we might do that, let's say, when it comes to something like the origin of life question. And there's a really interesting study that's highly controversial, published a few years ago, about whether or not Neanderthals made their way into North America about 130,000 years ago. And it's based on a site recovered not too far from where I live in San Diego County, where they recovered these remains of a mammoth that looked like it had been processed. And they concluded, well, this was human activity, but they couldn't date the site. And then when they finally figured out how to date it, the dates came in at 130,000 years ago. And so they were arguing, well, maybe this Neanderthals did make their way into North America. But the way they established that case was basically saying, okay, things look designed here. In other words, the arrangement of the fossil remains, they found cobble nearby. It looked as if this was processed. And then they ruled out, any kind of other explanation. It wasn't scavenged, by wild animals. And then finally they went in the lab and they took like the femur of a cow, the femur of an elephant, and they literally were striking it with the same kind of cobble, producing the same microfractures on both the bone and the rock. So they experimentally demonstrated the design. So this would be essentially a three-pronged criteria. And so when it comes to, like, let's say the origin of life, I don't think it's controversial to say that nobody really quite knows how life could have emerged through some kind of chemical evolutionary scenario. The issues that are confronting that explanation are legion. Now, I've attended origin of life conferences over the years. I've gotten to know origin of life researchers. I love hanging out with origin of life researchers. They're the most fun of any group of scientists there is. They are so inventive, so creative. They are so optimistic. and enthusiastic and about the problem that they solve. I actually think if origin of life researchers figured out how life originated through chemical evolution, they would be gravely disappointed in that accomplishment, because it means that all the fun problems that they try to address that are practically intractable would go away. So they loved the whole process of the problem solving. But yet, you engage origin of life researchers, and they're very quick to admit we don't really know what's going on. So, and then of course, I'm of the opinion that biochemical systems really do look like they have been designed by a mind. And there's a number of criteria we could apply. And then lastly, work in synthetic biology trying to create protocells demonstrates just the level of ingenuity required to create anything that's even a crude facsimile of what we see in the cell. So here we see a three-pronged set of criteria that match what an archaeologist or an anthropologist would use to establish design at an archaeological site or the activity of an intelligent agent. So my point would be, I think we already are at the point when it comes to the origin of life and the fundamental design of life, when we think about what Luca might have looked like or something like that, or we could say it really does look like we could establish that there very well could be a mind involved. And I think it's even possible to say, well, from everything we can gather, what kind of mind would this be? What would be at least some kind of parameters that we could apply? And so I don't think we're violating anything within the spirit of methodological naturalism, though we are now beginning to meld into the arena of metaphysics. But this would be an example, Cy and Steve and Misha, where I think we could actually push science into the arena where it's possible to begin to address questions of, is there agency that really is responsible for life at least in terms of its genesis, right?
Steve seems to have disappeared,
Sorry,
but I'm going to jump in.
Somebody.
Okay.
Good.
I agree with everything you said, Fuzz, about origin of life. But let me clarify a couple of things. First of all, for the audience, maybe some people don't know who Luca is. So let me explain that. Luca stands for Last Universal Common Ancestor. And Luca was a cell, a hypothetical cell. And it's considered to be the minimum possible biochemical entity that can exist as that gave rise to all the rest of life. And what's fascinating about it is that we know, because all life, I mean, one of our dear colleagues, Kent Hovind, who we all know, has
Go Kent, yes, our buddy,
has said he doesn't understand how pineapples and I think elephants, if I remember right, pineapples and elephants could be related. Well, pineapples and elephants, if you look at their cells, they're remarkably similar. They all have DNA. They all have the same genetic code. And by all, I mean all life forms. They have the same system of protein synthesis, which converts the genes into what the phenotype is, the way the cell actually works. And so we deduced that Luca, the last universal common ancestor of all of life, already had a tremendous amount of, as Fuzz was saying before, a tremendous amount of biochemical complexity, almost unimaginable. And then, of course, modern bacteria, which are much more complex than that, and not to mention all the rest of us, eukaryotes. So Luca, the challenge in Origin of Life is to get to Luca. And Luca could be considered the Big Bang. Okay, that's where life is evolving, for those of us who believe in evolution, like me, and is evolving into bacteria, is evolving into eukaryotes, is evolving into eventually animals, plants, and us. But you got to get to Luca, and that's very, very tough. And that's the challenge that I agree with Fuzz looks almost insurmountable. And I'm perfectly comfortable theologically and philosophically to say that yes, I agree that it was a divine agent, it was God. But I don't. But when I'm talking about it scientifically, even if I believe that God did it, as people like to say, I want to know how.
Mm-hmm.
And I think the path forward is to investigate how was life created, whether it was by God or whether it was a natural chemical process that involved no supernatural at all. We still want to know how it happened. And I think that that's an interesting route to take. Both, I mean, it's actually the same route, whether you're believe in God and God did it or you don't, you still want to know how it happened. And, you know, it's possible that someone will come up with explanations that all fit chemically and all are completely rational and reasonable. That has not happened yet in many, many, many different problems with origin of life. But it's not enough to just say, well, we don't know, so therefore God. What I think is we have to say, we don't know, so let's keep working. And maybe we should include the God hypothesis and see if that leads us to some mechanism. Now, I don't know how to do that. Okay, that's not for me. Somebody else is going to have to figure out how to do that. But I think that we don't give up on the scientific method when we reach a stumbling point. We have to rethink the scientific method, and we have to somehow go past that stumbling block. Like, why is the speed of light constant? Right, that was a big stumbling block, and look what it led to.
Yeah. Sorry for the and just to be clear, just to clarify, you know, I actually don't agree. Or, I'm sorry, I don't disagree with anything that you said. Freudian.
Will you find something you disagree with him on? Geez.
Not yet.
We're trying to. But,
we'll get there.
But just to be clear, I'm not saying, hey, we can't explain the origin of life, therefore God did it. I think that would be God.
Gaps. Yeah.
What I'm saying is, we don't know how life originates, but on top of that, boy, these biochemical systems really do look like they have the fingerprint of design. And on top of that, you know, when we were looking at what's happening in synthetic biology, again, it's showing us empirically how critical intelligent agency is in that to attain success. So when you put them together, I think you now have a scientific case that is beginning to push you towards agency as being the explanation. But I would agree with you. In fact, I would actually take the position that what we've learned through 70 years of work on the origin of life problem is that the chemistry and the physics that we need to support the origin of life actually exists through chemical evolution, at least in principle. But what we've also discovered is just how finicky and persnickety that chemistry is. And it works really well in a laboratory when you've got organic chemists setting up the reactions. But as soon as you start imagining what it would look like when you translate that to the early Earth, you now see really troubling scenarios where it doesn't look like that chemistry would be productive. And in fact, what I'm beginning to see in the origin of life research literature are concerns towards that end that maybe researcher involvement has actually produced artificial success in these experiments. And in fact, there was a paper published, I think it was Nature Communications. It was like an op-ed. It was called Prebiotic Chemistry and Human Intervention, where the whole point of that was, you know, we actually have probably generated a lot of false success. So to me, you're right. When you have a paper like that, granted, it was still an op-ed, but it's still, when you have a paper like that, you really are at the point where you're pushing against the boundaries of traditional or strict methodological naturalism, right? Because if the hand of the researcher is responsible for success, to quote Simon Conway Morris, you know, for all intents and purposes, that could be the hand of God. So, I mean, I think, you know, that you can still approach the question scientifically. I would still say that we should pursue, you know, chemical evolutionary explanations as intently as we are now. But at least it seems like we're being a little lazy to say methodological naturalism kind of constrains us. So let's not even begin to imagine what would it be like to try to incorporate an explanation that involved agency into the construct of science in a rigorous in a rigorous way, not in a way that makes mockery, but in a real rigorous way. And I think it's possible, but I think we don't try because I think we're constrained by the philosophy of science artificially, is my point.
Right.
Misha, do you want to touch on that real quick? I got a super chat and kind of plays into this as well, because I kind of look at it as, before they didn't know anything about any of this stuff, right? And we're learning more and more and more. And as I see what we know now compared to what we know then, and life to non-life transition, this abiogenesis you're talking about, we have narrowed it down. We're narrowing it down. And we don't know where that line of demarcation is. I mean, granted, there's a range there, and there's a lot of hypotheses out there. But every day, I think we get closer, and we're kind of limiting. And maybe right there in the middle, maybe there's something intelligent there. But I don't think we're anywhere near that point to determine that yet. But we're definitely getting closer than we ever were before. By the way, the only thing I disagree with Scion, I think Luca was a population rather than a single cell. But that's just how I learned it. But Luca was a population.
Absolutely.
Okay.
Thank you.
I corrected a biochemist. Score +1 for Steve. Yeah.
Hang around us long enough, and you'll be correcting us a lot more.
Right.
It's the small things in life that I have to like to point out. Okay, Misha, you want to touch on that? Oh, maybe the super chat real quick, because then you can touch on it.
Yeah.
Reed says $5. He keeps saying that we have no idea, but what about replacing the early conditions that gave rise to amino acids and RA first, etc. regarding abiogenesis? I think he's maybe asking, like, could amino acids, and this plays in what we're kind of talking about tomorrow too, where the proteins could be existing without, like, ribosomes. Could these things form by natural means, just by chemical processes, because of affinities and things dealing with chemistry, which is another topic that we're going to have one of these days. What's more base, chemistry or physics? Yeah. But Misha, you want to touch in on that?
Well, I would like to ask Fuzz if he could repeat your last sentence that you gave out. Just kind of rattled my brains a little bit. So if you could repeat it again, because I was looking at my notes and I missed it. Yeah? No, Fuzz's.
Fuzz, okay,
Fuzz's. I'm not quite sure what I said.
It's like it was one of those shots to the jaw that all of a sudden, wow, I need to address this, and
okay.
It flew right out of my head.
Complexities of biochemical pathways, something along those lines.
Yeah. I think we'll come up with it.
I think he's positing an abductive argument. It's basically from the last things he said, he's positing, hey, we've seen, let's say, like an arrowhead, right? We can see what an arrowhead looks like. We see what a rock looks like. This looks designed. My only contention is yes, we've seen things come from intelligence. We've never seen anything come from a disembodied intelligent mind. So even if things that have occurred from an intelligence have always been with a physical substrate. Now, with intelligent design, they've kind of bypassed that and said, okay, well, yes, we've seen things with intelligence, but now we're saying that this is a non-corporeal, disembodied mind without any kind of physical substrate. That's where I think the adaptive argument kind of fails. But you want to maybe go from there, Misha?
My question is this, and I'll make it as simple as possible. What does the fingerprint look like? Honestly, I would like to know. You're saying, we see the fingerprints of design. Okay. What does that look like? I know you talked about the anthropologists' tests. So what kind of tests do you run?
Yeah. Well, that's actually a great question, and it's a fair question. I just read an article, actually it was published in 2005, but I just read an article a couple of weeks ago written by Seth Shostak when he was talking about how does Ceti detect design. And he was complaining that the ID movement was misappropriating Ceti for their own ends. And so he was arguing that Ceti uses the concept of artificiality, that they were, I think, looking for kind of a oscillating pulse of light that would be monotonic, and that's unlike anything that you see in nature. And so I would actually agree with him that artificiality would be the criteria. So I'm not really looking at complexity, but really artificiality. And I actually am, one of my intellectual heroes is William Paley, and I know that guy gets a black eye quite a bit. But I think there's a genius to Paley's watchmaker argument. And as I've reflected upon his ideas for a couple of decades easily, maybe even more than that, what he was trying to get at with his watchmaker argument is, and he uses this term contrivance, in natural theology is that, when you look at an object that's designed, and you just use the watch as a case study, what you see is essentially this thing that's a contrivance, that it has these properties that are distinct from what we see produced through natural process mechanism. And, so when you look at biochemical systems, what I've done in my book, The Cell's Design, is I've cataloged what I think to be hallmark characteristics of biochemical systems that are identical to what we would see in, objects or devices or systems produced by human designers. So in other words, I call it the intelligent design pattern, where we're looking at what is it that human beings do when we design. That becomes kind of the pattern. And then can we apply that pattern to, biochemical systems? And, you could even quantify it if you really wanted to go that far using pattern recognition algorithms. But, you could actually say, okay, these are the set of criteria, and that we look at biochemical systems and we see that set of criteria. Now, the counter to that would be, kind of the blind watchmaker challenge of, that natural selection is producing that appearance of design. But this is where I think the work in prebiotic chemistry now comes into play, in that, but when we try to explain the genesis of life through, the blind watchmaker mechanism of chemical evolution, we haven't gotten very far. So in other words, I'm kind of following after Paley, looking for artificiality. Paley uses the term contrivance. I use a term intelligent design pattern, but it's essentially going from what we know that humans do, and by analogy saying, would this be a reflection of design? And I think Steve makes a really good point, but we're now talking about, quote unquote, a disembodied intelligence, or I would say a transcendent intelligence from my, theological framework. What would that look like? And, that's a fair question, right? And so the constraints of my approach, to be quite honest, is, the only example we have of intelligent agency at work are human beings. And so we're basing everything off of what human beings do. We're going from the known to the unknown. But I still think that even going from the known to the unknown, still it allows, I think, this question to be broached within the concept, or within the construct of science, though you are highlighting, I think, some very important issues. But I don't think those issues keep us from, I think, approaching this question scientifically. But again, I think, to be fair, you're bleeding into metaphysics, right? I mean, it's the same thing is true with the fine tuning of the universe. Mm-hmm. When you try to explain, this is the fine tuning problem. What does that mean? Well, now you're bleeding into metaphysics, right? But yet
it's all metaphysics.
What's that?
It's all good. It all eventually boils down to metaphysics. But I love what you said, and I want to emphasize this. I love what you said, the distinction between intelligence and artificiality, because complexity and artificiality, because complexity, okay, whatever. But if we had an artificial signal, like for example, if we looked at a pulsar and it wasn't just some kind of regular pattern, but if we saw like binary come out of it, or Fibonacci sequence, or something that was completely impossible to be natural, it was determined to be artificial, because we know this can only be something that is artificial when it has a binary code that's sending us signals. That would be obviously a sign of intelligence, right? So there's the thing with the intelligent design, though. They just assume that because we have the actual Fibonacci sequence, where we actually have binary, that itself is indicative of an intelligence. And I personally can't make that leap, right?
Yeah, I don't like if you're going to argue that information is a sign of intelligence, to me, what I don't look at the presence of information in biochemical systems as an indication of intelligence, but to me, it's how is that information structured? And I do believe that information in biochemical systems is structured in a way that we would structure the information as we created or generated as human beings. And there was a paper published talking about a biochemical grammar, where they discover this biochemical grammar that explains the way that domains essentially associate within protein structures. and then did a mathematical characterization of that biochemical grammar, and found that the grammar was eerie in terms of its similarity to the grammar that defines human language. Now, I mean, that's a really provocative finding, and you could interpret that a number of different ways. But from my perspective, that would be, again, an example of where we're using what we do as human designers as a template. And then when we look at biochemical systems and we see, oh, there's the same mathematical structure to quote unquote biochemical grammar as to grammar that defines universally human language, that now becomes a something where we could say, well, there's that now is, I think, a legitimate marker of design, I think, in the way that you were asking for, Misha. Right?
Yeah, but I think what to build on what Steve was saying and what you're saying, we've got Zeno's paradox going, and we have to figure out a way to measure both sides, not just keep on going with one side. We have to find a way to standardize. We need a metric that we can measure on both sides, both the naturalogical and the metaphysical, and I need a yardstick.
Right. Well, and I don't disagree with anything you're saying. And I think, to me, this is where, if I have a complaint with methodological naturalism, it's is that I think it's created artificial constraints that don't need to be there, that actually are preventing people from exploring the other end, because today, if you're in a chemistry department as a biochemist and you said, I want to work on trying to come up with a scientific program to measure whether or not agency was involved in the origin of life, you would have a really, really difficult time getting funding for it, though you very well could be right?
True.
But you could actually have, and so in other words, you're stymieing, and I'm not looking at a conspiracy theory or anything like. You're stymieing, I think, asking questions because you're right there at that boundary, and so that's where the limitations are. That I think may be actually hurting progress.
Yeah, I think it's fine to ask questions. Are you advocating some kind of we'll call it Science Plus?
Yeah. There we go. Hey, I got my humanism plus.
Yeah, we got atheism plus, humanism plus. Let's go for Science Plus. No, and again, I'm all for people asking questions, and I think that if they can actually make a legit argument, throw it out there. I've never been against that. I've never said, look, ID is so bad that we should never even look into it. I don't have that position. I just don't agree with it, and I think it's not scientific, and I do consider it somewhat pseudo, but that doesn't mean we can't ask questions. And it is a plausible hypothesis. I mean, there's no question about that. However, I just don't like when people posit it as, oh, this is the way it has to be. There has to be an intelligence. No, it's teleological versus teleonomic. I do think things are designed. Don't get me wrong. Look, the hand is designed to grip. I got no problem with that, right? But as Darwin pointed out, these things are teleonomically explainable. That was one of the big things that he showed people, that didn't have to be divine intervention or teleological or mind or anything like that. It could be designed by nature. So when biologists say things are designed, that doesn't necessarily imply a mind. It's just two competing, I hate to say worldviews, but definitely different positions. Yeah. But hey, I say ask those questions. I got no problem with that whatsoever. And I think you're right. It is stymied probably more than it should be, but I think it's the way they go about it. I think when you're like, when Intelligent Nine came out and it interjected themselves in the school system so heavy-handedly, and it was definitely just repackaged creationism. I think that really hurt the ID movement. If that was their thing. So
yeah, I couldn't agree with you more. I mean, we do a great job of shooting ourselves in the foot, and sometimes the people that wind up being the spokespeople for our position aren't doing the position any favors. Yeah. To be blunt,
Sai,
do you want to add on that? I mean, I think you're in that same kind of category, aren't you?
Yeah. I mean, I'd like to get into, while adding on it, I think I'm going to get into some areas where Fuzz and I may disagree.
Thank you. It's going to be political. Don't go politics, because we're
not
okay.
No. And that has to do with the design issue and what we've been talking about. And my point of view is I've said that I agree with everything he said about origin of life and the evidence for design, et cetera, and for all of life. In fact, the vertebrate hand is designed, the wings are designed. And my view is that once we reached Luca, by whatever means we did, we meaning, the universe, once Luca existed and was a population of cells, what then? How did life diverge into first very complicated single cells like bacteria, and then eventually eukaryotes, and then multicellular animals, and then plants, and then eventually, of course, us and other very complex animals. And to me, the answer is designed by evolution. And in fact, I mentioned earlier that I'm giving a talk next week, and I remember the title of the talk. It's Evolution, the More Intelligent Design. In other words, the evolution of biological creatures to occupy every niche of the planet, to have the tremendous diversity that you see in everywhere you look, and to have such incredibly beautiful, teleonomically oriented design, whether you're talking about a cheetah or a bird or a person. I mean, we have tremendous amounts of data and evidence that this occurred through a process of variation caused by genetic variance in a population, and followed by natural selection. And the data for that is very strong. And I don't see that as in any way antagonistic towards the hypothesis of a design creator, or a creator who designs. Because to me, evolution is the tool. Remember, I said before, I'd like to know how God created life. I think we know how God created the diversity that we see, and the tool that was used is this brilliant idea of evolution. And what really gives that credence to me is that evolution is often considered to be just a natural thing that life does, but it's not. In order to have evolution, you have to have a very specific and very complex set of biochemical mechanisms going on in cells. You have to have very accurate replication of the cell contents. And the way that happens is you can't replicate proteins. They don't self-replicate in any way. But you can replicate nucleic acids, and if nucleic acids have information that codes for proteins, you end up getting variation, and you end up with the possibility of evolution. So what I'm interested in is the origin of evolution, even more than the origin of life, because it's the origin of evolution that I think requires some kind of amazing design that we eventually see in all cells. So this may be kind of obscure, and I don't mean to go into great detail on it, but I think when I first became a Christian, and I've said this before, one of the first things I was worried about was that I would have to give up my scientific worldview, and it turned out I didn't at all. And I've always been a strong proponent of evolution. I've actually made some contributions in the evolutionary field. And I was very relieved to see that there are a group of people, Buzz is very familiar with them, called evolutionary creationists, who absolutely hold to the tenets of evolution. Now, some of them don't agree with me because I don't include evolution of life in that category. But I think I'm justified in doing that. But these are Christians who understand, or at least don't reject, any of the scientific information that we have about evolution, but incorporate it into their Christian worldview as part of the creation. So, I mean, that's something that I saw a fascinating video that Fuzz made a while back. I don't know exactly when you made it, Fuzz, but it was called "Why I'm Not an Evolutionary Creationist," and I really enjoyed it. Do you remember that video?
I do. Yeah.
Yeah. It was really interesting because I ended up agreeing with almost everything you said in that video. For example, that evolution of life and also human beings are not part of the regular evolutionary paradigm, and I agree with that. But if we exclude the beginning and the end, I'm still curious as to why you don't see this, the science of evolution as convincing.
Yeah. Well, yeah. Well, and to me, if I have to give kind of a nutshell answer, I don't have a lot of complaints about. I guess I'm kind of bridge a position between creationism and evolution. I'm kind of in a hybrid position where I do think there's really good evidence for, not only evolution within a species, but I think there's ample evidence for speciation. I'm comfortable with the idea of evolution happening at the level of a genus, even a family. Mm-hmm. But it seems to me that there are places where that mechanism of heritable variation that's operated on by selection or under the influence of genetic drift doesn't seem to be able to go from one regime of complexity to the other. So, for example, I've been spending quite a bit of time looking at the endosymbiont hypothesis, symbiogenesis, and kind of the origin of eukaryotic cells. And this would be another place where I think that those mechanisms that you're referring to don't seem to be able to get us from prokaryotes to eukaryotes. What's being posited is an entirely different type of evolutionary mechanism.
Yes.
But when you begin to look at the specifics of the endosymbiont hypothesis, where a lot of the work is focused obviously on the origin of mitochondria, kind of as a case study for that. I mean, the questions that are associated with that transition are legion. And so you have people pointing out that there doesn't seem to be intermediate grades between, prokaryotic cells and eukaryotic cells, or anything that would be kind of in between, documenting that transition. And this is referred to as the eukaryotic Big Bang. The last universal eukaryotic common ancestor is incredibly complex as eukaryotic cells are today. And so you seem to have this place where things are happening very explosively. It's a very rapid, seemingly rapid transition where you're going from one regime of complexity to the other. And then when you start looking at the specifics of what would have had to happen, I'm about to write up a blog article on the problem that the ATP-ADP antiporter poses to the models of symbiogenesis. So in what I'm referring to here is that mitochondria are generating ATP, which is the energy molecule that the cell uses. Well, this is generated in the matrix of the mitochondria, or the lumen, and it has to be transported to the exterior environment or to the cytoplasm of the cell. And when one molecule of ATP goes out, one molecule of ADP comes in. Well, other than organisms that are endosymbionts, nobody in nature has an ATP-ADP antiporter that works in that direction. Everybody, it works in the opposite direction. In fact, the very first bacterial cell that would have been hypothetically engulfed by the mother cell, where this alpha proteobacteria would give rise to a mitochondria, would have definitely had no motivation whatsoever to pump out ATP into the extracellular environment. In fact, when people have tried to look at the evolutionary history of the mitochondrial ATP-ADP antiporter, what they've discovered is that it doesn't match anything that we see in nature. Right. And so now you got this mystery. How do you explain where this biochemical property comes from? It doesn't look like this thing evolved from an antiporter that worked the opposite direction. I could see why you want to pump ATP into the interior of the cell and then just flip directions based on some kind of, collection of mutational changes. It looks like this thing is almost, designed specifically for mitochondria, quote unquote. And so that to me is an example of the kind of detail that when you press into that model, you start seeing a lot of problems. Or how do you generate the mechanism for protein import back into the mitochondria once you create this hypothetical nuclear mitogenome where you've got, information needed to encode mitochondrial proteins in the nuclear genome, because you have to tag each one of those proteins with a signal sequence that is going to be then, used to get that protein into the right place in the mitochondria, whether it's the outer membrane, the lumen, the inner membrane space, the lumen, or the inner membrane. And so you've got this very elaborate, complex machinery that seems to have to all assemble at once, plus getting proteins properly tagged. And so again, it may sound a little bit like the irreducible complexity argument, but again, when you look at that, this seems to me to pose a very real challenge, and yet it's the type of thing you would expect in a system that was designed. But I'm reading review articles on, the problem of how do you explain protein biogenesis in mitochondria. And this guy writing a review article says, I'm paraphrasing it, but in effect, it's like this is a very hard problem, but somehow it evolved, and that's the explanation that's being advanced, right? Yeah, and again, I don't want to make a God of the gaps argument, but the point is, so when it comes to even something like the origin of eukaryotic cells, to me, I think that as I'm beginning to really read into the details of what is required and what people are proposing and the problems associated with it, I'm beginning to wonder if this may not be a place too where, akin to the origin of life, there has to be some kind of agency involved. And so to me, I see places in the history of life where it just doesn't look like evolutionary theory as it currently stands can really explain this, and the prospects of that explanation don't seem to be on the horizon. And so now I think the next challenge would be, okay, what can we learn about this process from synthetic biology? People have just developed a model system to explore symbiogenesis using synthetic biology. And so those experiments that will come will be very interesting. And then also, are there features of the system that look like design, where we can establish design with some kind of rigor? That I think is work that needs to be done. But to me, this is another place where I just don't quite feel comfortable drinking the evolution Kool-Aid completely, and I would have at one point in my life, right? So there's other places. The Cambrian explosion is another place where I just don't see that transition happening with the mechanisms that we understand currently about evolution. And I'm not alone in this, because, like, for example, Jim Valentine and Doug Irwin have a textbook on the Cambrian explosion. It's a few years old now. And they're two of the world's leading authorities on the Cambrian, and they are of the opinion that current evolutionary theory can't account for the Cambrian. So again, I don't want to do God of the gaps where I'm just inserting God in there. I'm very much don't want to do that. But at least these are places where I think I'm scientifically justified in saying, maybe, just maybe, this might be a place where God may have intervened. So I kind of have a hybrid position, I guess, between being a strict creationist and being an evolutionary creationist. I'm kind of somewhere in the middle, but I want to make sure that my position at least has I can at least point to people in the field who are really experts in that particular area working on those problems, who at least at minimum would agree that there are outstanding issues here that really are, at this point in time, look like they are, if not intractable, are bordering on intractability.
So okay. So I do want to make it clear. By the way, I do agree that it was a very fortunate event that we have mitochondria, because I think you would all agree that we would never have enough ATP production in order to produce something like an animal. I mean, it just wouldn't be possible. I mean, that's the main source of ATP. So, but I think what you're saying is that you're not specifically saying, because we don't have answers yet for these specific things, there go God. You're saying we don't have answers for this, and if you're going to put God in any of those places, that's what they would fit.
Yeah.
Okay.
Yeah.
We are running out of time. We're coming up to 90 minutes, and we have your phone in 90 minutes, but we're going to try to get you back like we usually do. If you guys have something to wrap up, I do have some questions from.
Well, and I'm happy to go a little bit longer if you feel like.
Yeah, we'll keep. Okay, so 24-hour stream. Okay, we got it.
Can I just respond a bit?
Yeah, please, and then we'll get into some Q&A here.
So, I mean, obviously everything you said is completely true. We know that, but what I would like to address is when you said the word evolutionary theory, and as you know, the evolutionary theory right now is in tremendous flux. It's been changing tremendously, and I think the idea of gradualism or continuity in evolution, which was one of Darwin's original ideas, that's been shot down for quite some time. I mean, some of the great, starting with Gould and Eldridge, the idea of punctuated equilibrium kind of did away with that. And there are some people who still hold to the old gradualism idea, but they're not in the forefront of evolutionary biology. And instead, what we have now is what I find incredibly exciting, and this is not coming from theists, by the way. Most of these scientists are atheists, or at least agnostics, but there's something called the extended evolutionary synthesis, which is exactly trying to tie in those exact loose ends that you mentioned. In other words, just the idea of mutations following by natural selection doesn't seem to cut it, and that's true.
Yeah.
But what we now are looking at, what I'm not, but other people are looking at, are some fascinating new mechanisms for how we get variation, and rapid variation. I mean, you get things like transposons inserting into a control element, and all of a sudden 16 genes get turned on and you end up with a whole new system. And that kind of very complex and very rare genetic changes, which cause variation and lead to rapid changes in phenotype, seem to be probably what's driving many of these major transitions. I mean, it's known that, for example, the vertebrates, there were two big whole genome duplications at the origin of the duplicates. A very rare event, happens almost never, but it did happen. Your example of endosymbiosis is a perfect one. I mean, it probably happened twice, right, in all of life history, and we don't know. The points you raise are very good. We don't know how this, what appears to be irreducible complexity, the change in direction of a pump, how could that happen? Well, we don't know. But other examples of what looked like irreducible complexity have been somewhat explained by exaptation of previous structures. So it's not impossible that all of this fits into an evolutionary scheme, but it has to be a much broadened, expanded evolutionary scheme, which is why it's called the extended evolutionary synthesis. Now, that view is not universal among evolutionary biologists. There are some who say, well, you're not saying anything new, we already take that into account. That's not really true. I mean, some of the theories are actually quite remarkably extreme or radical or unusual, and some of them being proven true. So I think that if we take that into account, and this is actually in the form of a question, if we took into account the known new ideas in creating rapid and dramatic evolutionary or genetic changes, would you be more comfortable with seeing evolution as perhaps with some, I mean, I'm not disputing the idea that it's possible that there was more than one Big Bang in life. And by the way, we haven't talked about this, and it's not going to happen today, obviously, but the origin of humans. I mean, what about consciousness? Talk about a Big Bang. I mean, that's clearly not easily explainable by evolution, at least to me. Yeah. Whereas everything else, I wouldn't rule out. I mean, I think it's possible. I'm just curious what you would say about the extended evolutionary.
Yeah, well, and to me, I would just say that I see that as essentially acknowledging, again, the fact that current evolutionary theory just simply can't account for certain things. And, in some respects, it's almost kind of an implicit recognition that some of the criticisms that creationists have leveled against the evolutionary paradigm actually have legitimacy.
Right.
Right. But I'm quite open to what will happen with the extended evolutionary synthesis, and it very well may be that we do figure out how these transitions happen within an evolutionary framework. And if that's what the data says, then that's where, I'm happy to go. I'm happy to go where the data leads me. But, I think the point that you're making, and I think Steve made it as well, is that because these things are so rare, I mean, you can even see that again if you're looking at an evolutionary history of life, is there clearly is that the rarity or the unlikelihood of this happening could be taken as, again, having a divine mind being necessary for those kind of transitions. Now, one idea that I think is very provocative, and this is an idea that I've seen from Simon Conway Morris and some people that are kind of in his camp, where he looks at the convergence that we see in biology, right, and he argues that there very well could be like a biological anthropic principle, that there could be something within the laws of nature that are specifying certain biological endpoints, and that those endpoints are exactly what you need for life to be possible. And so I would be comfortable with kind of an evolutionary form of evolutionary creation that would say maybe it's, what we're looking at is life unfolding, but there was something rigged into the system so that it's only going to unfold in a particular way. And in fact, I'm actually starting a book on the possibility of a biochemical anthropic principle, where I'm actually arguing that I don't think there are alternative biochemistries. I think the biochemistry that we see in Earth-based organisms is universal biochemistry, and that there's a rationale to that biochemistry that seems to be fundamentally dictated by the very the laws of nature. Yet laws of nature are producing these constraints on biochemistry that are exactly what you need for life to be possible. So it's kind of like there's a fitness for purpose. Right. And I think that very well could also extend into all of biology. Now, if let's say if that view is correct, and it very well may not be, right? That let's say if that view is correct, then that's a view that I think people from both a creationist framework or an evolutionary framework could easily appropriate, right? Yeah. As evidence for the deep design that I think you were referring to, Cy.
Yeah. Yeah, that's
I was supposed to jump in here.
Misha, I don't know. It seems like
really quiet. Yeah, Misha's really quiet. I'm.
What is it? The
biology talk, and But before we get to her real quick, but Fuzz, haven't we kind of determined, or at least seen, the evolution of things, starting from a very basic protocell that had like an ion thing with sodium that could do basic motion with rotary, and then obviously we get into the rotary motion, a motor then going backwards for a pump. So we've seen it go one way with the VATPases into FPPases. We kind of can see the evolution, the step by step, if we're looking at integration by parts kind of thing, not to use a calculus term, but we've seen individual steps that is at least possible, because we've seen where the proteins come from the genes. So I agree that it is something where we go, okay, we may not know the exact steps, but I don't think it's outside the realm of possibility to say that, well, this cannot be completely natural, because if we start from the very basics of what would cause a rotary thing just by a sodium kind of a, I remember looking at the very, very basic cell that just had a sodium pump rather than what we now have for hydrogen ion channels for ATP. But it's a very similar process, right? So, I mean, do you not think that science should stick with trying to find the naturalist explanations, and then philosophy could look at more of the ID kind of thing?
Well, I mean, I'm perfectly happy with people, trying to probe these questions strictly from a mechanistic, framework. But I also think that, and I don't mean this in a derogatory way, but I also think too that many times we see, in evolutionary biology, we see these just so stories that are functioning as if they were genuinely mechanistic explanations. And my point, like with, the example we've been talking about with symbiogenesis, or at least the origin of eukaryotic cells, is that we've got this really nice just so story, but then when you press on it and say, okay, let me keep pressing on this from a mechanistic standpoint, you start to begin to see places where that story just doesn't quite hang together really well. And so to me, that's the play. Again, I'm not trying to do a God of the gaps argument, but I think that if we're going to go down the path of looking for a mechanistic explanation, we don't want to give, the evolutionary scenarios a free pass just because they are mechanistic or naturalistic in nature. I mean, I think we really want to demand of them the same kind of evidential proof that we would, or evidential support, I should say more appropriately, that we would of any kind of scientific model.
But are you positing a mechanism? If God, okay, again, I'm trying to steelman you too. That I don't think you're positing a God in the gaps, because there's a distinct difference between saying we don't have an explanation here. If the God's going to exist, it's going to be in here. It's different from saying we don't have explanation, therefore God, because one's a conclusion, one's a supposition. So I don't think that you're doing a God of the gap. So I want to agree with you there. But if it is God, then how do you actually get to a mechanism? Because there is, I don't know of any way we can say if God exists and he did this, what mechanism he used, because it wouldn't be a naturalistic mechanism unless you're positing some kind of God doing naturalistic stuff through naturalistic means, which makes no sense to me. It would be by supernatural means if he exists. So what would be a mechanistic explanation for something if God is the explanation? That's the part where I get confused on intelligent design.
Yeah, and I think that's a fair point. And a number of years ago, I had an interesting conversation with a patent lawyer about this very question. And so his question, to me, it was a rhetorical question, was, so what is the mechanism that an inventor uses when they come up with an idea for an invention, right? In other words, I think the point he was getting at was that when you talk about maybe agency being involved, let's say in a transition in the history of life, at that point, maybe, the mechanism question isn't actually an appropriate question at that point, right? Maybe that, you would look at that transition in some, you'd have to look at that transition in different terms, or it could very well be similar to what an organic chemist does in a laboratory when they create artificial conditions in such a way that molecule A will react to produce, molecule B, that maybe, this creator still worked through natural processes, but did it in such a way that's so artificial that, that clearly this is not something that happened independent of agency. And so, for example, when it comes to something like the origin of eukaryotic cells, I think similar to like I said earlier with the origin of life, I don't think there's anything in the laws of chemistry or physics that make the origin of life impossible. I think the chemical and physical processes we need to support the origin of life actually do indeed exist in principle. If the question is, could they operate productively on the early Earth, independent of intelligent agency, setting up some kind of artificial framework? And I think, likewise, when we look at, let's say that this idea of the origin of eukaryotic cells, I think we could say, well, we do see, and this is Cy's point, we do see mechanisms that could, in a sense, affect this transition. But the fact that it's so rare, and this seems to be the only way we're going to get complex eukaryotic organisms or complex multicellular organisms is to have eukaryotic cells. And if there is indeed evidence that we can marshal that looks like agency is involved, it still doesn't mean that there couldn't necessarily be some kind of mechanism involved. It's just that all the things that would have to happen at once to make that mechanism, those set of mechanisms productive, are beyond what we would expect to happen, through natural means, that there must be some kind of agency involved. So I don't think you have to abandon mechanism exclusively, or even if you did, maybe the question of mechanism might not be important or might not be relevant. So in other words, I think you've got two options there. I don't know if that was clear, but in a sense, there's two ways you could go if you're at that point and you say, I think there is agency involved at this point.
Do you want to add anything to that, Misha?
Well, when you're talking about mechanisms, you're finally getting into my wheelhouse. And
everything's her wheelhouse, by the way.
No, it isn't. No. When we're talking about innovation, especially mechanical innovation, we're talking, there's an anthropologist, I believe his name is Michael Brown, who divides it into disruptive innovation and sympathetic innovation. Sympathetic innovation meaning that you're just making rational, logical advances. See also, your thumb drive gets every year more and more and more memory put into it. Your computer gets smaller. Your car gets better gas mileage. Disruptive innovation is, of course, the iPhone. But when we're talking pure mechanism and this idea of innovation, we're not talking about systems that are self-replicating. And I think that's a big factor that has to be taken into consideration when we're talking about pure biological mechanisms, is the very fact that that self-replication process is so different than, all of the part of the earth that we as human beings can manipulate.
I guess everybody agrees with that.
Oh, I love that. I mean, I think
she has a way of putting things right.
Statement. Yeah, it's right. I mean, we take it for granted because all life self-replicates, but nothing else in the universe self-replicates.
That's kind of. Well, I mean, well, RNA's not life, and that self-replicates.
It doesn't self-replicate very well.
Okay, well, but it still can. But yeah, obviously, fidelity is a big issue to be had. Granted.
Yeah, well, that. No, but I think Misha really has something very important.
I know Fuzz wanted to go a little longer, but I do got to keep this down to a certain amount so it's digestible for people, because people do watch these and this is amazing. These are three questions that were asked earlier. They're probably very tangential or not even related to this, but this is fine, and we don't have to get too deep into them. Maybe we can discuss them afterwards, but they're from people that I know. Okay, so one person asked, this because we're talking about philosophy of science, so again, don't have to get too deep in this, but how does hard determinism affect philosophy of science? And I think this is more for maybe to Fuzz, because you at RTB, you have this model from kind of a guided process, especially from the theistic guided evolutionary process, and also that you think that maybe God is actually doing minuscule changes constantly to kind of direct things, as opposed to a hard deterministic approach where everything is just, like you said, mechanistically done. I'm more of a compatibilist, but that involves more free will. But do you think that in the philosophy of science it is more deterministic, or you think that is deterministic, but there's also an agent that is influencing that determinism? Really weird way to state that, but I don't know how else to ask it.
Yeah, I'm not sure that I've thought about it enough to actually give a reasoned answer.
Sock account asked that, so it's going to be a bizarre question. People in the
well, I don't know if it's a bizarre question. I think it's actually a good, it's a good question, but I've not thought about it enough to really give a
fair enough
answer. Yeah.
Okay. Is Dr. Rana familiar with structuralism in Evo Devo?
I'm not sure if I know what that means.
I've heard of structuralism, and I know what Evo Devo is, but I'm not familiar with enough of the topic to even weigh in on it either. Dr. Garte, maybe?
Yeah, well, structuralism actually is a fascinating idea that came originally from, I think his last name was Owen, I think Richard Owen in the 19th century.
Oh, okay. Oh, I know it.
It's Michael Denton's view. So you know what that is.
Yeah. Brief synopsis then, because I'm not. I've heard the term, but I'm not that familiar with it.
I guess I've referred to it as archetype.
Oh, process structuralism. Is that what they refer to it as, process structuralism?
Yeah, it's related. I mean, it's very much similar to what Fuzz was saying before about Simon Conway Morris's ideas of natural laws. Although Simon is not a structuralist, but the idea is that there are natural laws which lead to biological outcomes that are more powerful or can substitute for natural selection. And probably there's some value to that. I like to mush them all together because I don't think it's one or the other, which is kind of my standard mantra. I never think anything is one or the other. But so structuralism, yeah, I mean, I think it's an interesting idea. The idea of natural law in biology is one that has not been explored enough. I think Conway Morris is one of the pioneers when he looks at constraints, although that whole work has not been developed into law-like mathematical structures yet, but it probably will be. And I think there's a lot of that. The whole realm of gene regulatory networks, which is a fascinating area that I got involved in a couple of years ago, just had a paper published on it, is one that kind of speaks to that idea of structural law that determines an awful lot of how biology works. But we're just at the begining of that.
Yeah, and as I was looking into it, it kind of jarred my memory a little bit. It's relating to the actual structural morphology of an organism, how
right.
evolution affects the morphological changes. Right.
Right.
One more. This is again to Fuzz, but Dr. Garte can chime in. Fuzz has an interesting take on CRISPR-Cas9 techniques in his Humans 2.0. Somebody wanted to ask a little bit about that. And I think you were talking about the other day on somewhere. I don't remember where it was, but weren't you talking about CRISPR-Cas9 and Human 2.0?
Yeah. And just a bit of a shameless self-promotion.
Please.
I just had a book published in July with a friend of mine, Ken Samples, who's a philosopher, and it's called Humans 2.0. And it's kind of a Christian perspective on the transhumanism movement and the idea of using technology to enhance human beings. And kind of we look at it scientifically, philosophically, and theologically. And my view on CRISPR-Cas9 gene editing technology is it's exciting technology that can be transformative in terms of biomedicine. I'm strongly supportive of that kind of progress. And yet, there are the prospects of potentially using that technology not only to correct genetic disorders, maybe even eliminate genetic disorders from the human gene pool if you want to apply it to embryos, but that raises a whole set of ethical issues in and of itself. But it also could be used for potentially human enhancements for designer babies, or maybe even going one step further and enhancing human beings beyond our current biological limits. And that type of advance fuels the transhumanism movement. It gives the transhumanism movement suddenly academic credibility like it's never had before. So that idea is moving rapidly, from my perspective at least, rapidly into the academic mainstream. The idea that we can use science and technology to take control of our own evolution and to usher in a post-human age. So we talk about CRISPR-Cas9 technology in the book and kind of how it's contributing to the transhumanist movement. But my concern is that Christians are going to have a knee-jerk gut reaction against transhumanism that will be non-productive in the sense that there's going to be condemnation or just refusal to acknowledge that this is actually possible, and as opposed to actually engaging our culture in a productive way with the transhumanist movement. Because I think there's a lot of things that transhumanism is aspiring to that I think as a Christian we can affirm. The idea of using technology to mitigate pain and suffering and to promote human flourishing are very much ideas that are consistent with the Christian worldview. But I think what Christianity can contribute is a robust ethical framework built around the image of God concept that every human life has inherent worth and dignity. And so it helps to, I think, counterbalance maybe the enthusiasm of applying this technology without giving appropriate thought to what would be the ramifications. So Christianity provides a framework that promotes this kind of work, but also at the same time protects those people that could potentially be exploited by the technology or marginalized. And it also is a framework that really would advocate for a just use of that technology so that there's equitable access to the technology for all people. So those are kind of some of the themes that we deal with in the book. But it doesn't have much to do with the philosophy of science.
Well, I think it kind of does. But doesn't, if it isn't that more along the lines, you're saying that maybe there's some Christians out there that think there might be people stepping on the dominion of God, because that has been an excuse for thousands of years against science, that, oh, this is God's territory. That doesn't really fly in modernity very much. But I think there is an issue to be had with gene editing, where you start working with that germline, and you don't, as I had mentioned, when you're talking about the complexities of gene expression and all the other things, and we found out the hard way because some Chinese doctor decided to quote play God and do germline editing. We don't know how that affects other genes, right? That I don't think we have beginning to understand those things. So it's going to take decades, if not hundreds of years, for us to even, I think, have a really decent understanding of that, because it's that complicated. But I think it could be one of those things that could be used for good, or it could totally change humanity. It could actually wipe us out if we're not done correctly, if it's inserted into the germline. So I think it's a fascinating topic that I'd love to have a further dialogue on when it comes to transhumanism. I know there's some other people in the community that have been talking about it as well, and especially with CRISPR-Cas9. So maybe that's something we can table and come to the discussion another time on that, because I'd be fascinated by that. So. But we do got to wrap it up. Fuzz, as always, man, I'm so thankful to get to bring you on and talk to you. I'm very grateful for the fact that Reasons to Believe has been so great to the channel. I met, by the way, Ken Samples. He was great as well. I'd love to have him on to talk about something. And we still got to get Kenny back as well.
Oh, yeah.
Yeah, he was great. And in fact, again, I got to tell you, when I went to the AMP convention, I was actually a little surprised how well I was treated. And I don't mean that in derogatory means, but I was like the odd man out kind of thing. But they were all very friendly, very just amazing. I got lots of books to read. It was a very joyous experience. So that's the kind of the discussions that I want to have, right? I want to have theists to come on that can able to discuss things and do so from their actual positions, because I hate pose. I really cannot stand people that posit a position that they don't hold. It's a waste of everybody's time. So I'd rather have a theist that really believes things and can come in and articulate their arguments. That's what I've always looked for, right? So I thank you for that.
Well, and it's always a delight to hang out with you guys. I've enjoyed the time with Misha and Cy. You guys, it'd be fun to get together and just hang out over
anytime.
A beer, right?
Let's
just
do it. I'm down for that. I drink beer.
But I really appreciate what you're trying to do too, in terms of, I think, promote a genuine dialogue and interchange that's civil and meaningful, on these really important questions. I think that this is refreshing to me to be able to participate in. I've always felt like you and everyone has treated me with the utmost respect, though not always agreeing with me, but I've always appreciated that.
And you've answered you attempted to, and I think, in some degree, you've answered my questions. I mean, there's been 3 or 4 questions I've asked on Facebook, and you've taken them and ran with them on, your own Facebook page. And I'm thrilled with that. I'm honored that, my questions are not so bizarrely wrong to where you go, well, Steve, that's kind of a dumb question. Don't be asking that. That's my worst fear, is when smart people say, damn, that's a dumb question, Steve. But Misha, always a pleasure to see you as well. Thank you very much. Anything you want to promote on your channel? Because you got a new channel. Oh, go ahead, Fuzz. Yes.
I was just going to say, could you give me the you said Michael Brown was the one on innovation. I'd actually like to read.
Oh, Dr. Rana, I'll if you could make sure I get your email, then I can send you the PDF.
Okay, thank you. I'd love to read that.
I'll give you guys all contact information. That's easy.
Great.
Okay. And Misha, you want to promote your channel real quick?
Well, we're still working on a program. We're kind of hampered by vacation stuff and everything, but you can see Jerry and I on History Unsettled. We're going to be taking on the Roman Empire and the Roman Republic soon.
That's going to be interesting. And I love all these new channels popped up. I mean, we had your channel popped up, Digital Hammurabi popped up. I have a friend named Epic Math Time. He's a mathematician. He popped up recently. He's like 8,000 subs already. I was like, dude, wow. It took me like 6 years to get that. And you got it in like 5 months because, he's really good at what he does. So I'm so glad there's new channels coming up. Cy, what about you? Anything?
Well, I may be popping up with a channel too at some point soon, but I haven't been able to get to it because things have been very hectic and busy. So I have no channel to promote, but anyone who's interested in some aspects of the nexus between science and faith can look up the magazine God and Nature at the ASA website, American Science Affiliation website. I have a blog called The Book of Works, and that's the address, The Book of Works. And if you're interested in my book, the title is The Works of His Hands. And it's a partial memoir of my journey. Actually, I realized I actually stole the subtitle from Fuzz without realizing it, because I saw I saw the same phrase on one of his posts, but the subtitle is A Scientist's Journey from Atheism to Faith. And it's very close to what Fuzz had written. So, and part of it is a memoir about how I came to Christianity largely through science, and there's some science in it as well, including a couple of chapters on evolution and related areas. So that's being published by Kriegel. It'll come out in November, and I'll be publicizing it on Twitter and Facebook and stuff like that.
Awesome. All right. Well, with that, guys, thanks for joining us tonight. Again, Fuzz, I'll message you guys always
Sure.
this information. And I want to thank the live chat. I want to thank my mods. This was a great discussion. I love these types of discussions. They're free form. They're just exactly what I started this channel doing, along with the great debate community. This is what I thrive on. This is what I think people really do want to see a lot of. And even though I have a lot of stuff on my channel, this is something that I plan to do like at least once a week or something like that, have people come on and talk about these different topics. But with that, guys, thank you very much. Like, subscribe, and all that other YouTube stuff.